in this meeting, we are going to uh, talk about the laws of thermodynamics. So we have all in all four laws of thermodynamics. So the the first one is the zeroth law. Then ikaduha ang first law, katulo second law, kaupat si third law. So here in this lesson, ang duha lang kay maraman po'y nabutang sa module ang first law o ang second law of thermodynamics. So let's start with the first law. And I think siguro na naman, 'di ba, na mo subject karon nga thermodynamics, so maybe this is just a review for you kay siguro nahuman naman ning first law. Kay wala murag kuan day nadungan man day inyong physics ug ang kanang kuan thermo. So this is just a review for you and let's review sa inyong kanang kuan topics pud sa thermo para ma-refresh mo. So let's start with the first law of thermodynamics. So when we say kuan class thermodynamics, thermo, so from this kanang word kaning thermo, it means heat and dynamics, the movement. So meaning it talks about the transformation of this heat energy. So again, heat is not a property of material, but it is an energy that can be transferred from one form to another. Nga makiri siya sa ka material para po i-transmit sa other material. So for the first law of thermodynamics, it talks mainly on the conservation of energy. Okay, conservation of energy, meaning energy cannot be created nor destroyed, but can be transformed from one form to the other. So another is the transformation of energy. Transformation of energy. So unsa may bot pasabot niini? Let's say if we have a kay since conservation and transformation man siya, so let's say we have a motor here. Okay, na motor connected to a bevel gear. Unyan atay glass of water. Then natay paddle ari. Okay? So as this motor kanang operates, so mutuyok niya ang paddle and then na may water ari, so mutuyok ni siya and then the temperature of the water here mo rises siya. So meaning we have here from the motor, of course we have here uh, electrical energy to mechanical, and then from mechanical, so since we input work to the water, so the mechanical energy is converted into heat energy. So manang miinit hing rise ang temperature sa tubig. So basically the first law of thermodynamics talks about this one. And for the first law, okay, for the first law, for an isolated system or for a certain system, so I hope naka-familiar na mo atong mga different types of kanang kuan system. So can you give me example of a type of system class? Nakahibawa mo mga klase sa system? Any idea? Na may idea? Wala idea? Sa type system? So okay, open or close. So we have open, close, and isolated. Let's say for example, we have here a system. Okay? So I have here a system and 'di ba? Ang utlanan sa system sa tawag na this is the system boundary, 'di ba? Na mo na system boundary. So system boundary. And of course, this is our kanang focus atong thermodynamic analysis kanang siyang box nga colored black. So in a system, based on the first law of thermodynamics, if I'm going to input heat, okay? Kung mag-input kog heat, let's say ako ni painiton. So in this way, I input heat which is Q, PQ. And in a certain system pod class, okay, wait lang na mag-join, na nag-join. So in a certain system pod, of course, it has a working substance. Okay, so sa ka-system, naagid na, kung mag-analyze mo kuan, di gina mawala ng working substance. Of course, unsa man mo analyze kung kay material nga present. So here, let's assume that this is water. Water is our working substance, H2O. So, as the water gets heated up, okay, kung tubig mainit na of course, the three basic nga kana mga parameters. So we have three basic parameters here. We have what we called P, the pressure, V, the volume, and the temperature. Okay, mao na sila mag-vary because this is a property that defines the state of our water, whether ang tubig kay tubig ba siya, ang tubig kay ni ice na ba siya, or ang tubig transform ba into steam. Kaning tulo mo na siya mga basic parameters that will define the state of our working substance, which is our water. So as we add heat to the water, according to first law of thermodynamics, of course there should be a transfer of energy. Di pwede nga i-absorb lang tanan sa tubig. So ang kuan ani, by the first law of thermodynamics, conservation of energy and also the transformation of energy, meaning kung nag-init sa tubig, of course, ang iyang internal energy, so when we say internal energy, it is defined as U. So U, meaning this is internal energy. Okay, internal energy, and other books denote this as delta E. Okay, same na siya. So kaning Q, mo resulta ni sa gitawag nga increase or iya gi-modify ang internal energy. So that would be U. Okay, internal energy. Kung sa ato pa, sa tao pa, ang atong kanang kuan, atong body heat, okay? Murabag nanginit imong kuan, imong lawas. So murag mo na internal energy. And then aside from the internal energy, of course, due to these properties here, the pressure, volume, temperature, of course, this water would also exert, since mo taas po na possibility nga mo change yung pressure, either mo taas, so it exert pressure on the walls of this system. So meaning it does what? It does work, di ba? So naay work nga hitabo. So therefore, pag init nimo, dili lang kay mo change ang iyang internal energy or iyang kumbaga kainit sa iyang sulod. Napod siya mahimo nga trabaho, and we are going to denote this one as work. Okay? So here, from the first law, mo ra gini pinaka basic nga definition sa first law, the formula. Okay, formula for the first law, formula on a given system. So again, this is our system. So the formula for the first law is just we're going to equate the energy nga misulod sa system, that is the energy input to the system, is equal to the energy nga migawas sa system. Okay, and para di mo maglibog, okay, para di mo maglibog, ang kana atong ipasabot nga system is it could be our working substance. Okay, kay in a certain problem daghan jud kay mga given, dagay mga paraphernalias, dagay accessories. So para di mo maglibog, kana i-considered ang working substance as the system. Here atong working substance kay tubig. So from the point of view sa water, unsa pay input nga energy? Of course, syempre ingon mo ko diri nga nag-add ko og heat. So therefore our input energy is Q. Okay, that is the heat. And then what would be the output? Okay, ang output, so tungod sa pag-init nako, midako daw ang internal energy. So therefore that would be the output. Okay, increase daw yung internal energy. So that would be U, our internal energy, plus what else? So since si H2O kay exert ng pressure given these parameters, so it does work. That's why we have W here. So therefore, the general equation for the first law of thermodynamics states that the input heat is equal to the change in internal energy plus the work done by the system. But these three right here, kanya akong gi-present dire. Okay, kanin tulo, Q equals U or delta U plus work. Actually, kung nyo kitaon, simple lang kasi ang formula, but if na natin mga processes, dira na magka-complicate. So atin siya tagsaon. And then of course, kaning Q, okay, kanin silang tulo ka buok, dili na siya all the time nga positive because Q here can be positive or negative. Okay? Q, and also the internal energy can be positive and negative, and work positive and negative. Okay? So in what case, sir, nga si Q, si internal energy, si W mag-change og sign? Again, let's take a look back, or let's have another example of our system. Let's say this is our kanang kwan system. This is our system, and let's say our system is the working substance nga water. So if ever, di ba, sa ato ang basic nga kanang formula for the first law, that is Q is equals to internal energy plus work. So kanus aman mag-negative si Q. Now mag-negative si Q if init na siya daan, nagpagawa siya og kanang heat. Okay? So we have Q out. Okay? So say pasabot anang nagpagawa siya og heat, that is heat loss or Q loss. So gawas. So therefore, kani sila depende sa direction kung unsa ginimo gi kuan gi add sa system. Now if nag-input ka sa system, that would be a positive. So positive ni siya. If nag-output ka sa system, okay, or nagpagawas ka, that would be negative. And the same thing with the work, but not with the internal energy. Okay, for the internal energy, when we say positive internal energy, so ako na po i-connect ari. When we say we have positive energy, it indicates that we have an increase in internal energy. Okay, internal energy. And then, if we have negative internal energy, what does it mean? It means that we have a decrease in internal energy. Okay, in internal energy. And later on class, mag-derive po ta sa internal energy as a function of temperature, because this internal energy is closely related to the temperature of the system. Okay? Kaya di ba ang giingon ninyo ganiha, kani internal energy mo na siya ikaw nga murabag kanang increase imong kanang body heat. So kung mi-increase imong internal energy, meaning nanginit ka. If mo decrease imong internal energy, meaning namugnaw ka. So that's why mo na siya ang mga signs. And for work, the work is the same with the heat. So if we have an output work, that would be a positive sign. So output work meaning work, okay, work done by the system or by the fluid, okay, ang or atong working substance. And then for the negative work, this indicates that the work is done on the system. So meaning that is an input work. This one is an output work. So output work positive and our input work negative. Okay? So mara na siya ang kanang kuan, ang basic formula for our first law of kanang thermodynamics. But in the first law of thermodynamics, we're going to talk also the processes. So daghan jud gani mga processes, because just by looking at the basic formula for this one, okay, ato balikon og so what, that is Q is equals to internal energy plus the work. So here, internal energy ato sa i-defining internal energy, and syempre kaning work, and lastly the Q. Okay, ato na ikuan. So let's start with kuan. Let's start with the internal energy, U. Okay, so U, internal energy, is defined as a function of temperature ni siya. So U is equals to the mass of the object, and then CV, that is specific heat at constant volume, then change in temperature. Mo gini ang formula gid, ay ni kalimti. This is the formula for our internal energy. However, for our work, the basic formula for work, okay, the basic formula for work is, di ba, sa ato ang previous nga lesson on kinetic energy, or even the basic formula for work, that is work is equals to the force times the distance or displacement delta x. And in thermodynamics, this can be derived. Okay, this can be derived further. Why? Because let's say we have here a tube. Natay tube ha. Natay tube. Of course, we have a working fluid nga misulod. And then of course, we have here an area. And since this fluid, let's say man siya ang fluid, since ang fluid may travel, so therefore it has a displacement. Let's say this is delta x. Mo na ang na-displace sa fluid. Okay? And diba, by the basic formula for work, that is work is equals to the amount of force exerted by the fluid times its displacement, delta x. However, since mostly ang gi-represent sa fluid is in terms of pressure, diba? Fluid is represented in terms of the parameter pressure. And we all know that pressure, diba? We all know that pressure is equal to force over area, right? So therefore, this force here is equal to the pressure times the area multiplied by the displacement. Now, if we're going to assume all systems into a smaller cylindrical piece, so cylindrical piece, diba ang volume for this figure is just the cross-sectional area times this displacement. So therefore, we can say that this one is just pressure multiplied by the change in volume, or in calculus that is P dV. Okay, P dV. So therefore, the general formula for work applied in thermodynamics using the parameter pressure is equal to pressure times the change in volume. So mo na gi-exert, okay, mo na gi-exert either ha, di ba, again ay to kalimti ang work kay duha to gi-exert either ngadto sa fluid or sa atong working substance, or ang working substance ang mi-exert ana sa surroundings. Okay, so mo na siya ang basic kanang formula ng atong tigaman, because from here we are going to apply these two formulas kani siya kaning for the internal energy, U is equals to mcv delta T, and also this one PdV, in order to derive the formula for different processes. Kay naman tayong mga processes sa first law of thermodynamics. Okay, so let's start with those processes. So namin pangutana, so far nakakuan mo class? Nagets ra? Okay ra, walay pangutana? Okay. The first law of thermodynamics, so kuanta, we have kanang different processes, and let's start with the first one. And for the first law of thermodynamics, ato lang ikuan nga this is for non-flow nga process. Okay, so nakaibaw na ba mo kaning difference between the non-flow and kaning flow nga process? Na-discuss na ninyo sa inyo sa termo ninyo sa kalahian ani non-flow og flow nga process nya. Unsa lang mga example sa real world, kay ang pag-analyze manggod mo na lisod sa pag-analyze og mga problem sa thermodynamics, ang pag-differentiate aning non-flow and flow. Kay actually sa daghan jud formulas ang termo, and then basig magkarambold ang inyong pag-select sa formula, basid ang formula for the flow process inyo magamit sa non-flow, and then ang formula pud sa non-flow magamit inyo sa flow process. So here ang atong mga processes nga atong i-tackle diri is for non-flow only, kay sa inyo termo mo naman to extension kaning flow na ato flow nga process. So unsa may mga good mga examples sa non-flow process? So for non-flow nga process, mo ni siya, let's say we have the common example, piston cylinder nga arrangement, wherein naatay air inside the piston, inside the cylinder nya gi-push siya against sa piston. So naatay air dira. Manay basic example sa mga non-flow process. Kay tungod diri wala may, di ba, walay kanang kuan, walay ni flow nga fluid or working substance kay nagsteady ra siya inside the cylinder. Kaduha, we also have an evacuated container. So evacuated or rigid container. So nara sa ubos. And then inside this rigid container is our working substance. It could be air or water. And then yan po nga case, we apply heat. Okay? Apply tag heat. So this one is an example of a non-flow process. And what else? Katulo. This one is for rigid. Okay? Rigid container or evacuated or insulated rigid container. So man siya kay para di mo maglibog kay mao gini mga common example sa mga mga problems nga naa sa thermodynamics. And katulo is we also have kanang kaning sa balloon, di ba? Balloon. Okay, common po na siya. So kaning balloon pagka buntag daw kuno dako siya, then ni pagkagabi kay migamay. So kana this is also an example of a non-flow nga process. So nana siya kaning sa balloon. And then for the flow nga process, mao na siya pinakadaghan. Okay? And then napaday additional sa non-flow. So naay kaning siya yun sugatan sa termo. Kaning naay rigid container, then naay partition, naatay space A and space B filled with working substance and another working substance but of different temperature and pressure nya gi-remove nimong partition, so unsay resulting properties ana nila. So man siya may example sa non-flow nga process. But for the flow process, mao na siya daghan kaayo, and then mao gini siya ma-apply gid sa ato field. The first one is for turbine. So if naka-familiar mo og turbine, this is a system that follows the flow process because the steam will enter. So ang steam will enter, so ang steam diri mo na siya ang atong working substance. Ang steam that would cause the turbine to rotate, and then of course magawas gyud ang steam pod, so steam out. So therefore here nagflow ang ato ang working substance, unlike here stagnant siya. Aside from turbine, so this is turbine. So di daghan kani. We also have nozzle. Okay? So we have nozzle. Kana. So nahaing in nga, let's say this is fluid. Okay? Fluid inlet and then fluid outlet. Okay? Fluid outlet. So kani siya, nozzle is a flow process. A device that follows the flow process. Okay? What else? We also have compressor. Okay? So napatay compressor. So we have input. Napatay input array nga working substance. So let's say this is refrigerant in refrigeration system. Input refrigerant and output refrigerant. Then kani siya gitawag na siya compressor. So ang compressor, it follows a flow process since ang refrigerant kay may enter din may pud may exit. Man siya example, and actually daghan kay example sa flow process. So mana siya, and here we're just focusing on the non-flow process. Okay, sa non-flow sa kay mao ni ang basic pod foundation sa thermodynamics, non-flow process. So let's start with the first one ning gitawag nga constant volume process. Okay class, what is the other term for a process that follows a constant volume? Zaman, na may idea unsay line term, okay, especially sa mga problems na uban nga di man i-state nga this kaya siya nga type of follows a constant volume process. Na may idea unsay other term for a constant volume process? Ha? Isometric? Okay. Another term niya sakto. That is isometric isometric or uh, is isochoric. So mana siya isometric or isochoric. So mana siya constant volume process. So mayo kay na kay ba man ni. So for a constant volume process, again this is for non-flow process, and ato na i-drawing daan para nyo ma-visualize ang system. So let's say this is our system. So again non-flow ha, meaning wala mi wala input nga kanang fluid nya, wa po may out nga fluid. So meaning may stay ra siya within our system. So suppose this is our system, then we have here a certain substance inside. Okay. So again, constant volume process. So in this process, we are going to define those three. Okay, those three. Katong heat, Q. So ato tayo pang define. We're going to define those three. We have Q, we have internal energy, the work, and also na ako i-add this one S. Are you familiar with S? Say pasabot ang S class. Entropy. Okay, sakto. Entropy. This is entropy. So when we say entropy class, that is the amount of disorder of a certain process. So ang kakatag ba then another pud ana is mo na siyang energy class nga wala na use sa kuan. Energy nga murag kanabang wala gamit in order to do work. Okay? Kay ang other kuan, ang energy nga nagamit nato, especially kanang turbine no, di ba? Ang kanang energy nga nakapa-generate nato og kuryente, actually that is due to the kanang kuan enthalpy. Kaning entropy mo na siya ang wala nagamit in doing work. Mo na siya ang energy nga wala nagamit in doing work, and also it measures the amount of disorder of a certain process. Mo na siya. So upat ang ato i-define ani for this process. So we're going to define unsa kahay Q niini, unsa kahay internal energy niini, unsa kahay work niini for a constant volume, and also the entropy. Okay? So let's start with the work. Okay, mag-una ta ni work. Let's start with work. So work. Again, work is defined, W is defined as P D V. Okay? Or ato i-extend, that is P, then that is V2 minus V1. And if we're going to graph this in our PV diagram, so in the thermodynamics, daghan kini mga diagram class. Mapuno yung diagram ini. We have TS, temperature versus entropy, and we have PV, pressure and volume. So if we're going to have a graph for this process, so using PV, okay, PV. So since ingon siya nga constant volume, so meaning pa straight line, since V is our abscissa, so nadiri ang 1, then to ikaduha 2. So mo na siya ang graph. If makita mo straight line sa PV diagram, this is an isometric or isochoric process, meaning our V2 here, V2 is just equal to V1. So therefore, kani siya diri magiging 0. Why? Because V2 is equals to V1. So therefore, if this would be 0, automatic our work is equals to 0. Work is equals to 0. So therefore, for a constant volume process, our work is 0. Okay, take note niya na. Kaduha, let's proceed to the internal energy. Okay, internal energy. Internal energy. Again, di man ni mag-vary sa internal energy. Automatic, ang formula for internal energy is U is equals to the mass of our working substance inside in our system here, and then the specific heat at constant volume, followed by the change in temperature, that is delta T, or in expanded form mCV, we have T2 minus T1. Of course, in our PV, na po na siya corresponding po dira nga temperature line. So this would be the formula for internal energy at constant volume. Mo na siya kani di ni mag-usab gyud. Most of the time ang internal energy di mag-usab sa anini processes, siguro kung maabot na lang tag isothermal, mausab na internal energy. Kaya nga sa thermal kay constant temperature man to, but later on nato siya. So after internal energy, kanang kuan, let's proceed to heat Q. So the heat kuan energy. It could be an energy that is added on the system, mata kay baw, or an energy nga na loss sa atong working substance. So for heat energy, just follow the katong first law, formula for the first law of thermodynamics for a non-flow system. That is Q is equals to U plus work. And since our work, ingon mata si work 0, si work daw is 0, so therefore our Q is just equal to our internal energy. So whatever heat nga gi-add sa system or gi-loss sa system, that is just equal to the change in internal energy. Either ang internal energy may increase or may decrease. So therefore, pareha lag formula ang Q sa internal energy. That is Q is equals to mCV T2 minus T1. More siya class, basically. And then finally, okay, for our kanang gitawag nga entropy. Entropy, the amount of disorder, denoted as S. Now, just take note with the general formula for entropy. So, di ba, ganiha, gihatagan na tamo general formula for work, that is PDV. General formula for internal energy, mCV delta T. General formula for the first law of thermodynamics, Q is equals to U plus W. And here, the general formula for the entropy. So take note with this, the entropy is defined as the derivative of Q is equals to the temperature multiplied by the derivative of S. So therefore, we need to integrate para makakuha kita sa exact nga value for our entropy, which is our S. So therefore, in solving for S, okay, in solving for S here, how to integrate? That is, so diri this would be equal to ds is equals to dq over t. So integrating, that would be equal to integral of 1 over t then dq. So ingon ana siya class. And here in our example, or if walay change, we can just say that this is q all over t. So ingon na siya class. And here diri class, kay diri sa ato example, our ds is equals to dq integral of dq over t. And here, our q is equals to mcv delta t. And since we have delta t, so we can also say that this one, ito bring down na diri in solving for the entropy. We can also say that that is dq is equals to m cv delta t. Okay? Ingon na siya. So therefore, pwede na nato pwede na nato i-substitute sa ato formula. So we can substitute this one here. Okay? Because nganong gi-dq man ako. Nganong na-dq man sir? Because pasabot po, the other term for delta t is also change. So therefore, if the temperature change, of course, automatic, ang kaning q mo change po ni siya. Therefore, substituting to our equation, that would be s na lang ni, kay gi-integrate mo na to. S is equals to the integral of mcv dt all over t. So since the m here and the cv are constant, so extract that one inside the integral. So we have mcv integral of dt over t. That is from temperature 1 hanggang temperature 2. Okay? Class, nano mo integral karon no? Nano mo integral karon? So makarelate naman ni. Makagets naman ni. Kani siya nga process sa pag-integrate. Okay, so what is the integral of dt over t? Sige daw. What is the integral of dt over t? This is okay, ln t. So very good, sakto. So this would become m CV, then ln of T, wherein we have limits from T1 to T2. So substituting that one, it would become mCV ln of T2 minus ln of T1. But using the property of logarithm, so this would be simplified into mCV ln of T2 over T1. Okay? Diba? Naman tayo property nga ln of x minus ln of y, that is just equal to ln of x all over y. Naman tayo nga na. So therefore, our entropy for a constant volume process is just equal to mCV ln of T2 over T1. Ingana na siya. And then, don't forget class, diri mo mas naiuban diri masangit. Diri nga part kani siya. Okay, sa entropy, naka-lone ni siya. Take note, T2 and T1 alone. So, inyong kanon diri is be sure that the temperature here is absolute. When we say absolute, just use either for metric Kelvin, for English Rankine. Ayaw paggamit og degree Celsius kay automatic malahi imong answer. Again, in this case, ln T2 over T1, please add, okay? Add 273 if that is degree Celsius, and add 460 if that is degree Rankine. Kaya nga naman, basig aban makancel naman na sir kay division na siya. No, dili na makancel tungod kay addition ang operation. So therefore, don't forget to convert your temperature into an absolute kanang scale nga temperature. So maran siya. Again, atong work 0, internal energy is just the kuan katong mCV delta T. Ang heat is just equal to internal energy kina 0 ang work. Our entropy, we already derived this one. So just remember this. Kanina lang, dq is equals to TdS. Okay, TdS ra gyud, and then using your principle sa integral, so mara ng mCV ln T2 over T1. So kung miin kag what is the entropy of the system kana following a constant volume process, so you can use this, the last one. Okay, so walay pangutana regarding sa first nga process. Wala na? Okay, so let's proceed to the next one. So ikaduha, we have the constant pressure process. So unsa may pasabot, unsa may other terms sa constant pressure process class?
Isobaric.
What else?
Isobaric.
Okay, isobaric. Unsa pa man? Actually na pa. Napa may lain nga nakuanan? Nasabtan? Okay, for a constant pressure, it is also known as isobaric. Isobaric or isopiastic. So, kuya kay term no. Isobaric or isopiastic. Muna siya, constant pressure nga kanang process. Isobaric or isopiastic. So, again, ato na po ikuan nga atinumduman nga non-flow ni siya ha. So we have here a system, non-flow gihapon, walay exchange of kanang fluid in or out. So nara siya within the system only. So nara non-flow man siya. And then of course, we're going to plot this kanang process in our PV diagram. We have here pressure and then volume. So since this is constant pressure, of course we have a horizontal line. So gikan diri padung adto. So horizontal gid kay constant pressure man, that is this is the initial state padung sa final state. So ay horizontal line ang iyang representation sa atong PV diagram. So constant pressure, makita kay mo point 1 to point 2 nga horizontal line, constant pressure din na automatic. So let's define these four parameters: Q, W, internal energy, and the entropy. At constant pressure, so una ta ni work. Ni work at constant pressure. So again, for work, the general formula is W is equals to P dV. Or that would be P V2 over V1. So since this is constant pressure, so meaning ma-apply ni siya kay if di na siya constant pressure good, ang kwan ani ay formula mo good kay mo siyang P2V2 minus P1V1. However, since both the initial pressure P1 and the final pressure P2 are equal, so therefore mo na ma-factor out na siya. May mo siyang P V2 minus V1. So therefore, mo na siya ang formula for work at constant pressure. That is P V2 minus V1 or P dV. So take note. Mo na inyo take note. The next, we have for the internal energy, U. Okay, for internal energy, for constant pressure, diba, as what I have told you, ang formula gid for internal energy is still U is equals to mCv delta T, or that is mCv T2 minus T1. Okay, maragin na ang formula for internal energy. Balik ra. Maging ayun na siya kalimti. Next, we have Q, or the heat Q. Okay, ang heat Q, ang pag-derive nini is using the basic formula for the first law of thermodynamics. We have here Q is equals to internal energy plus the work. And we all know that the internal energy is just mCv delta T plus the work here is P dV. Okay, P dV. So that would be the expression for our Q. However, we can still reduce this one. Okay, ato pa ni siya ma-reduce. Why? Because if we have, or ato i-denote ha, in ideal gas law, di ba? Sa ideal gas law, this only applies for gases. In ideal gas law, we'll know that we have this formula PV is equals to MRT, right? That's and then, if we're going to take the smaller increment for our volume, of course, automatic mo change put and temperature since constant si pressure. So therefore, we can say that that would be P delta V is equals to MR delta T. Okay? Okay, in this class, in this process, the constant pressure process, if we're going to apply this for our kanang gases, okay, for gases, we have a relationship of this one. We have V1 over T1 is equals to V2 over T2. Okay, but this can only be applied for gases. Ayaw ni apply sa tubig basig pure water at certain volume and temperature niya. Yun i-apply V1 T1 because V2 T2. Actually, di na magana kay lahi ang process for water. For gases, this one is for gases only. And of course, for the constant pressure process for gases, ang other term niya is Kang Charles. Diba? Kang Charles law man eh. This is Charles law. Okay? So, mana siya. And here, we have P delta V is equals to MRT. So, therefore, we can also rewrite this as P dV is equals to M R delta T or dt. Pwede siya. So, therefore, ang P dV day can be written as MR delta T. So, pwede na nato i-substitute ara. So, therefore, our Q now would become Q is equals to mCv delta T plus that would be MR delta T. Okay? So, muna siya. And then, na-common nga mga variables. So, we have here M delta T, common nila, multiplied by CV plus R. Class, does anyone of you knows the other kanang parameter nga mo represent sa sum of this CV and R? Unsa may equivalent anang CV plus R? Kani. What is the equivalent for the sum of CV and R? Na idea? So, dapat idea ni? Actually, this comes from the Mayer's equation. Mayer's equation from lesson 1. Okay, nana siya sa Mayer's equation. Wherein Mayer's equation states that the relationship that exists between these three parameters, Cp, Cv, and R, okay, the gas constant, that is equivalent to Cp equals Cv plus R. So therefore, ang dili ay ang atong Q magiging mo naman siya, may M Cp na din siya delta T. So therefore, the general formula for our Q here is equals to M Cp delta T for constant pressure, because of course Cp here is the specific heat at constant pressure. So muna siya ang formula for our Q, mCp delta T. And this mCp delta T, actually na siya other term. Okay? Ang sabi pangalan na yun na may idea on say other term for this aside from Q. Sa may lain term aning mCp delta T nga kanang kuan expression. Na idea? Na may idea, class? What is that? Actually, pero nakaabot mo sa yung termo og enthalpy. Kaabot mo? This is just the enthalpy. Okay. Man siya tawag enthalpy. So we now have enthalpy, internal energy, and entropy. So diri nag-root ang enthalpy. Enthalpy represented by the alphabet or the letter H. Enthalpy H. So we have here a new parameter enthalpy, which is equal to mCp delta T. Okay, so mana siya ang heat. And the last thing is we have for the entropy. So we have here entropy. Again, don't forget sa basic formula sa entropy, that is dq is equals to T TdS. Okay, dq is equals to TdS. And we all know that our dq is just mCp delta T. That would be mCp delta T, then equal to T ds, and then divide both sides by T. So we have ds is equals to mCp ato lang i-rewrite into dt. Okay, anyways equal na siya all over T. Then integrate both sides para makuha na to ang S entropy from T1 hanggang T2. So that would be S is equals to ato ni extract ang constant mCp integral T1 to T2, then that would be dt over T. So here the integral of this one is ln. That would be mCp ln of T2 all over T1. So muna siya, class. This is the formula for our entropy at constant pressure. So muna siya. Marami yung hinumduman, class. So again, you can have Q as mCv delta T plus PdV, or you can just have mCp delta T. Ato naman na-derive. Then entropy, muna siya. So naay pangutana so far. Naay pangutana, class. Wala, na-gets ra? Okay, so if wala pangutana, then let's proceed to the third process. And we are going to call that one as the constant temperature process. Okay, human naman si volume, human na si pressure. So, si kuan na lang. Si constant temperature na lang ang process. So we have here the third one. We have constant temperature nga process. Actually, gamit kaning constant temperature process especially sa kanang sa pag-derive sa Carnot cycle. So, unsa may other term for constant nga temperature process class? Any idea? Unsa iya equivalent nga name? Okay, isothermic. Sakto. So, this is an isothermic or isothermal nga process. Okay, isothermic. Now, for an isothermal process, so again, ato lang isuwat na lang tong kanang kuan PV. Okay, for PV actually ang representation sa isothermal is mara siya nag-curve. Okay? Nag-curve siya pa ana. So that is from point 1 then point 2. And another koan, okay? Another graph is we have for the TS, meaning this is temperature versus entropy. So TS here, ato na makit-an nga straight line and temperature because for an isothermal process that would be as a horizontal line, meaning ang temperature kay constant, that is from point 1 to point 2. So muna siya yung representation sa duha ka diagram. So here for an isothermal process, let's define again kung unsa ka ang Q, unsa ka ang internal energy, ang work o ang entropy. So let's start with the work here. So work. So again, the general formula for work, that is W is equals to P dV. Mara siya. And then here, isothermal. Okay, you can have this, but we need to kanang ato na siya i-express as kanang another expression para makakuha in terms of P1 and V1. Okay, since this is a process, so we need to transform this nga naa natay mga terms or mga variables nga P1 o B1 or P2 or V2. So we all know from ideal gas law. So from ideal gas law, okay, if this is an ideal gas law, so that would be we have PV is equals to MRT. Okay, and since this one is constant, so therefore we can say that that would be equal to a constant C, but C is just equal to MRT. And then here we can solve for P. That is, P here is just equal to you can have this MRT all over V. And then we're going to substitute P in our equation here. Okay? Ato na i-substitute dira. Okay? So since wa man natangtang si kanang delta V, so therefore we can also say that that is delta W is equals to P dV. Integrating na pod, integrating both sides, that would be W is equals to, substituting the value of P, that is MRT dV all over V, then that would be from V1 until V2. So constant man si MRT, constant man ang MRT, so therefore ma-extract na siya outside, that would be equal to MRT integral of V1 to V2 dV over V, and of course ln na pod, so that would be MRT ln of V2 over V1. Okay, so again this is just the same, so nagagikan na siya sa MRT multiplied by ln of V2 minus ln of V1. Yan siya. And then, balik na pod, okay, going back, di ba, MRT is just equal to PV. And then, di ba, we have a relation from here. Since we have PV is equal to constant, therefore we can say that P1 V1 is just equal to P2 V2, which is equal to MRT. So therefore, we can represent here the MRT in either way. You can have, pwede gali, this one is equals to P1 V1 ln of V2 over V1. Or you can have here P1 V1 ln of P1 over P2. So, asa man ni ma-verify sir nga equal na siya. Of course, from this relation, since we have constant temperature, so therefore, this is Boyle's law. Okay? Boyle's law man siya. Kang Boyle's law man eh. Boyle's law, we have relationship P1 V1 is equals to P2 V2. So therefore, kaniding V2 over V1 is just equal to P1 over P2 is equals to V2 over V1 out from this expression or equation. And then, what else? Since may other equivalent ni ana. Actually, we can also use P2 V2 ln P1 over P2. Anyway, same ra gina sila class. So therefore, man siya ang expression for work. So daghan kig possibility kanang possible formulas for work. Anyways, all of them are equivalent, just equivalent. Okay? And this one only applies for gases. Again, this one only applies for gases. So for gases only. Kaya ni gamit ang mutaning from ideal gas lang PV is equal sa MRT. So mana siya. At constant pressure for gases, that is P1 V1 ln V2 over V1. So depende ra kung unsay mga available nga given sa problem. So you can use either of these mga formulas. Next, let's proceed to the internal energy. That is U, internal energy. Internal energy, again, U is equals to mCV delta T. Class, naabatay internal energy at constant temperature? What do you think, class? Because this one, ma-expand ba na siya? Mahiuning mCV T2 minus T1. So, naabatay internal energy kung isothermal process? By looking at the formula, class. Naa ba? Wala, nga naman. Okay, so sakto. Kani siya, ma-zero na siya. So therefore, for an isothermal process, the internal energy is equals to 0. Of course, kay ako nagikon ninyo nga internal energy is a function of temperature. So the internal energy here is 0. Next, ngadto ta sa heat. Okay, sa heat energy or Q. Again, basic formula for the first law, that is Q is equals to U plus the work. So here, since we all know nga si U kay 0, therefore, our heat nga na loss or na gain is just equal to the work. Okay? Q is just equal to the work, or that is equal to kadto siya mga MRT ln V2 over V1 or equal to P1 V1 then ln P1 over P2. So, ikaw na bahala kung saan mo gamiton. So, mana siya class. Ang heat. Mana siya ang definition sa kanang heat. Maybe may heat loss ka or may heat gain. So, mana siya ang mga formulas. Then, after this, let's proceed to entropy. So, pinakalas ang entropy. Entropy. So again, for entropy, represented by S. So that is dq is equals to T ds. Okay, T ds. And here, we will know that this is ds is equals to dq over T. And we all know that q here is a function of T, that is mRT ln V2 over V1. So we can substitute that one for our dq. So that would be mRT ln kanang V2 over V1. Then divide by kanang kuan, divide by T. Okay? Mo na siya. And then kuan day, sorry. Ato day ato din siya take ang derivative pa sa q. So kana siya. So kani ato siya na siya i-derive. Di ba? We have q here. So we'll know that q is equals to mRT then ln V2 over V1. Okay? And then kung ato i-take ang derivative sa q, so we have derivative of q with respect to the temperature. So here, i-treat na nimo kaning si M, si R, og si ln constant nara kay T. So therefore, mabili na lang niini is we have mR ln V2 over V1, then mara na siya. And then kuan, pwede kuan ato lang po ni i-multiply ngadto si dt. So mahimo na siyang dq is equals to mr, okay, ln of v2 over v1 tapos dt. Okay, but okay, I forgot ang kanina siya. Okay, di na to makuan, sorry kani siya di na ni pwede kay ang t day diri kay constant naman din ni. I forgot. Kani siya, we cannot take the derivative here kay ang q kay wa naman siya function because all of these are constant. So therefore, the derivative is automatically 0. So must take data tong first. Again, dita magkuan og integral ni ini kay mas 0 naman siya. So sakto nito gani ha. Ang q diri kana siya mahimo ni s is equals to q over t. So again, nga naman since wala na derivative sa s kay since ang q na po diri kay wala na change since iya value is equal to the constant. So kani diri all these parameters here are already constant. So the mass, the r, the temperature, the v2 and the v1. So that's why magiging s na lang ni is equals to q over t. And then s is equals to q is mr t ln V2 over V1 divide by the temperature. So again, constant naman yung tanan, so makancel ni. So since common man si temperature, kani makancelled. So therefore, our entropy is equal to S equals to mR then ln V2 over V1. Okay? So, mo ni class ang expression for our entropy. So, in order to check for the units of entropy, kay ang unit sa entropy ato na i-check. The unit for entropy is equal to kilojoules, that is energy per kilogram. Then we have degree Kelvin or per unit temperature. Ay, sorry, wala din siya. Wala na mass. That is kanang kilojoule per degree Kelvin ra. So kilojoule per degree Kelvin. Ato siya i-verify sa atong nakuha. So sa atong nakuha diri nga formula, that is mass is in kilogram, assuming kilogram. The R, the universal gas constant is the R of a specific working substance is kilojoules per kilogram degree Kelvin. and then this lone V2 over V1 makancel mang unit, therefore unitless ay tapad, so unitless ni siya, so kanira de siya, so makancel ni, so therefore we have kilojoules uh, per degree Kelvin, so sakto gid siya sa tong giingon nga ang unit for entropy is kilojoules per kilogram because that is heat per temperature. So unlike work and heat, kay ang work ang kanang I mean ang unit sa work kay either kilojoules or joules, even internal energy kanang kwan siya, kanang kilojoules or joules gihapon, the same with our Q. So mo na siyang entropy for an isothermal process, MR lone V2 over V1 or P1 over P2. So na pangutana ni so far. Question? May pangutana? Walay pangutana class? Okay ra? So walay pangutana din. Let's proceed to the last process, and ang pinaka-last kay gitawag nato og adiabatic or isentropic process. Actually na pa day last, but anyways, related naman gud ang last. Related ra ang last. Okay, so for the next we have the fourth one, which is, diba, human naman tong mga three basic parameters kadtong pressure, volume, and temperature. So ang ikaapat wala na nila, and we are going to call this one as adiabatic. Adiabatic process. Class, unsay pasabot sa adiabatic process? Unsay other term for adiabatic process? Ha? Okay, isentropic. So, kanay siya adiabatic process. This is also known as the isentropic process. So, isentropic. Okay, and then here, we're going to know those parameters katong Q, W, and then U, and S. And then we also have an additional parameter here for adiabatic process. Okay, so let's start with the substance air, or let's draw first there sa katong iya representation sa atong PV og sa TS. So PV, actually ang iyahang drawing sa PV medyo steeper siya nga pagka-curve, so may ana siya diri ana, meaning this is 0.1, 0.2. Kani siya mura na siya adiabatic expansion. Then for our TS, since this is isentropic, so when we say isentropic class when we say isentropic, our entropy is constant. Okay? Entropy is constant. Mano pasabot? Isentropic. Entropy now is constant. So here, straight line na siya. Ana. Straight line siya sa TS. Okay, and what else? For an adiabatic process class, when we say adiabatic, walay heat nga mi. Saman, walay heat nga mi transfer. Okay, walay heat nga mi sulod or migawas. So no heat transfer. So when we say adiabatic, means that we have no heat transfer in or out of our system. No heat transfer. So automatic, so may pasabot na kung kuan adiabatic. Unsa man ang atong Q class? What would be our Q? Unsa man? Unsa man ka atong kuan ani? kay if walay kuan heat transfer ang ato ang Q is equals to 0. So Q is equals to 0. Okay, if we have a system, let's say we have here a system. So, may example sa mga kuan class, mga adiabatic nga process is that i-state na dito nga for a non-flow system, itang is properly insulated. So, if na mga kuan nga kani siyang tank kay properly insulated, okay, insulated unya or kanang kuan kanang murag mo ni ang pinaka kuan more common kani insulated nya surrounded by kuan nga no heat loss. So assuming no heat loss or heat transfer, no heat loss and kanang kuan heat gain. So muna siya mga kuan class mga adiabatic process. Kay if insulated gay atong tangke, syempre wala gay mo gawas or musod sa system, di makagi. So again kani siya nga heat is moara tong kuan is moara tong either mo mosulod or mo gawas na Q. But anyways, napo na siya gitawag nga iyang kaugalingong heat ang kuan ang object, I mean ang working substance. Mo to ang una, we have the U, the internal energy ay magkalibog internal energy, and then ang usa is H, we have the enthalpy. Okay, enthalpy, internal energy and enthalpy. So again, bahalag mag zero ang ato ang heat input or ang migawas, nagyan tay values nini for the internal energy and the enthalpy. So let's start with the work for an adiabatic. Okay, and then ato pag-derive ani is let's start with the sample of air or the working substance air. Okay, kay for other kuan class, for other kanang sana other nga mga kanang kuan gases, ang ato ikuan na is polytropic na siya nga process kay lahi naman ang value nila. So for air, we introduce another parameter known as the specific heat ratio. So I hope familiar mo aning specific heat ratio for air, that is K. K is equals to 1.4. That is for air, but for other gases lahi na kanang value niya. Okay, and then for an adiabatic process class, especially for air, it follows the relation. Okay, mo na niya yung gisunod nga relation, that is ato doing array, ato i-write, that is PV raised to K is equals to constant. So therefore, if we have this, then we can say that from state 1 to state 2, the relationship exists wherein pressure 1, volume 1 raised to K is equals to pressure 2, volume 2 is equals to K. So from here, makaderive ta og nagkalahi-lahi nga mga relationship between pressure. Okay, we can have a relationship here between pressure, we have temperature and volume. So for pressure and volume, may siyang relationship. How about for kanang kuan pressure and kanang kuan temperature? So this is for air air is a gas. So for kanang kuan pressure and temperature, so mato siya, di ba? We all know that from ideal gas, okay? From ideal gas law, so kanang kuan we all know sa ideal gas we have PV is equals to MRT. Okay? PV is equals to MRT. Or kanang kuan we can say that V, okay? V here, V is equals to MRT over P. And we can substitute V in our equation here, this sa taas, para makakuha tayo ang relationship that exists between pressure and temperature. So here, mahimo na po na siya og P1, then V1 is mrt1 over p1 raised to k is equals to p2. Then we have another mr, then t2 over p2 raised to k. Actually, kani, since si mr and mr common sa duha, so pwede na siya makancel out even if naka-raise siya sa k. Anyways, makancel na siya. So here, we have p1, then 1 minus k, then t1 raised to k is equals to p2. We have 1 minus k, then t2 raised to k. Then combining, okay, at siya combine, so this would become t2 over t1, so itong gibaili, then raised to k is equal to p1 over p2. Okay, so I mean t2 over t1, oh sakto lagi. So t2 over t1 is equals to kanang p1 over p1 over p2. So p1 over p2 then raised to 1 minus k, and then ato i-raise na pod og 1 over k para mati over t1 na lang, so 1 over k. So we have t2 over t1 is equals to p1 over p2 raised to kanang 1 minus k all over k. So mo na siya class, mo na siya ang relationship for temperature and pressure. Ang last is we also have a relationship between temperature and kanang volume. So ingani na po ang pag-derive, you just use the ideal gas law and kanang kamo na lang mag-derive na class. Anyways, ma-derive na siya ninyo. So again, that for air, mo na siya ang relation PV raised to K, especially for isentropic, magina siya PV raised to a certain exponent, and for air that is K. So mo na siya, and then let's proceed to the derivation of its work. So let's start with work. So work for in non-flow again ha, non-flow ni siya. So work is defined as katong diba W is equals to P TV, okay? Or you can have here the derivative of W. But we all know that P, okay, naman tayo relationship nga PV raised to K is equals to C. And dividing both sides by V raised to K, so we have now P is equals to C over V raised to K. Then we're going to substitute that one here. So it would now become, himon na siya og derivative sa work is equals to C over V raised to K, then dV. Integrating from V1 to V2, so we have work is equals to, extract the constant here C, integral of dV over V raised to K. Or we can have it C, this is V1 over V2, V1 over V1 to V2, then you can have V raised to negative K dV. Since K is constant, so the integral here W is equals to C, then we have sorry, atasan erase. So we have here C multiplied by V1, then that is 1 minus K all over 1 minus K, then from V1 to V2. So work would be C over 1 minus K, then we have V1 V2 raised to 1 minus K minus V1 1 minus K. So here I can distribute C. I can distribute this constant C. Dire ako na siya i-distribute. So we now have 1 over 1 minus K multiplied, this one would become CV2 1 minus K, and then minus CV1 1 minus K. But we all know, class, nga ang C is a constant. And if we have two states, going back here, kaya sa taas, di ba, we have P1 V1 raised to K is equals to P2 V2 raised to K, which is equal to a constant C. And this C is equal to M R T1 or M R T2. So yan siya. So therefore, we can substitute C. We can substitute C either P1 V1 K or P2 V2 K. So for the first term dire sa C, ako i-substitute si P2 V2 raised to K. So this would now become 1 over 1 minus K. Then C here is, I can have P2 V2 raised to K multiplied by V2 1 minus K. So I've choose this tungod kay na possibility nga ma-cancel ana ay ma-combine si V2K dire og si V2 1 minus K. And also with the second term si C times V1, so ako i-choose kaning P1 V1 kay na ay possible nga ma-cancel, so that is P1 V1 raised to K multiplied by V1 1 minus K. Okay? So what's left, since they have the same base, so i-add ni mga exponent, that is 1 minus K plus K, so cancel ni mga K diri. So the remaining would be 1 minus 1 over K, then multiplied by P2 V2 minus P1 V1. Okay? So basically, mora gina siya, class. Or you can also modify this, ang kaninga work. You can extract P1 V1, so you can have P1 V1 1 minus K, then the result here would be kuan ni siya, mahimo ni siya og kanang P2 over P1. So we have here P2 V2 over P1 V1 minus 1. Okay? And as we all know, okay, from here, class, di ba? In this relation, kaya siyang relation, kaya siya, di ba? Ang ratio aning kaning P2 over P1, kung ato na siya i-modify, P2 over P1 is just equal to, that is V1 K over V2 K. So pwede mao na siya ang ato ang i-substitute ari. So kanit siya substitute na diri sa ubos, diri sa P2 para in terms of V1 na lang. So therefore it would now be equal to, may equal na siya to P1 V1 over 1 minus K, then multiplied this one, mahimo na ni og V1 over V2, no? So V1, and then V2, actually na siya K, and then si V2, then V1, V2K po na siya, minus 1. So therefore, by manipulating the exponent of the variable, magiging si V1, maka na siya, K minus 1, and si V2, may siya K minus 1 sa ubos. So therefore, that would be V1 over V2, that is K minus 1, minus 1. So basically, ingana na siya, class. So actually, dagay mga forma ni. And that is the derivation for the work for an adiabatic process. Actually, you can just simply use this. Kasi if given ang pressure and volumes, then you can also use this kanya siyang relationship kaning PV raised to K is equals to C. You had P1 V1 kana siya. Okay, so mana siya ang for work. So nabay question ani? Again, this is non-flow, ha. Nay question ani, class? Nay pangutana? Are you still following? Okay. So, since suma naman si work, so let's proceed to the kuan. Proceed ta sa kanang iyahang uh, internal energy. So, for an adiabatic process, okay, ang ikaduha, so for letter B, we have internal energy. So, for internal energy, again, U is equals to katugyapong normal, mcv delta T. So, man siyang internal energy, that is mcv T2 minus T1. So, man siya ang for internal energy. And then next, we have uh, Q, or the heat added or extracted by the on the system. So, heat added or extracted. Since may makalabas o makasud sa ato ang system since adiabatic man, so therefore the heat transfer, again ha, heat transfer ni siya, it is different from the enthalpy. So the heat transfer here, Q, is equals to 0. The next, we have the enthalpy, that is H. This is enthalpy. Okay, so the system, even if it is adiabatic, still has an enthalpy. Of course, nasa enthalpy, that is H is equals to, diba, kaniya ito na derive, that is M Cp T2 minus T1. So this is the formula for the enthalpy for adiabatic. Ang adiabatic, naragin na siya enthalpy class aside from the previous, more on Q is equals to internal energy lang yan na. So here, the last one, pinaka last, is the entropy. S, which is the entropy. So for entropy, since this is isentropic, automatic, S is equals to S2 minus S1. So since S2 is equals to S1, so therefore S here is 0. So we don't have change in entropy in our system. So muna siyang adiabatic process, especially for air. Again, air, we are using K. So standard for K, that is the specific heat ratio, that is 1.4 for air. Mana siya. And then the last, but not the least, kaning polytropic process. Anyways, ang derivation is the same lang sa atong gikuan ganiha, and also the heat added and the enthalpy is still the same. Iyan ang nakuanan is you just replace K by N. Okay? For a polytropic process, so polytropic. For a polytropic process, just use P V raised to N is equals to C. And then of course automatic, the work here is 1 over 1 minus N, then natong P1 V1 minus P2 V2. So maring ni siya class for a polytropic process. Ang N diri kay depends upon the substance. So for a polytropic kanang kuan process class, mo na iha gi-follow kanang PV raised to N. Okay? PV raised to N is equals to kanang constant. And then its internal energy still the same gihapon. Okay? Ina na siya class. So mana siya ang for polytropic kanang process. Okay, so let's have some problems para ma-practice. So by the way class, na may ni klase. Na may klase karon. Wala, okay. So okay ra padayon ta. So padayon ta. Okay, wala kami klase. So we have here some problems. So let's start with let's start with this problem 1. So we have here a closed system executes a series of processes for which two of the three quantities, so the work, the heat, and the internal energy are given for each process. So find the value of the unknown quantity in each case. So for let's start with letter A. So here, letter A, we have work is equals to negative 35 kilojoules. So if this is a negative work, meaning this is an input work, meaning gisud sa ato system, input work. And then we don't have Q, so manatong pangitaon. Then internal energy is equals to negative 35 kilojoules. What it means that our system uh, may decrease po iya internal energy, unya may decrease po diyan temperature. Okay, decrease in temperature, hinani siya. So by the basic formula for thermodynamics, first law niya, so we have Q is equals to internal energy plus work. So kipangita si Q, just substitute lang. So copy the signs good. Negative 35 kilojoules. Work is negative 35 kilojoules also. So the result would be negative 70. Negative 70 kilojoules. So unsa may interpretation ani ato answer, class? What would be the interpretation of this answer? Meaning, unsa man? We reject heat. Okay, gi-reject niya negative 70 kilojoules. Wala siya gi-input nga sa system kay negative man. So, it means that we reject heat. Manay both pasabot ana. Let's proceed to letter B. So, for letter B, we have work is equals to 1.2 megajoules. Then we have Q is equals to 645 kilojoules. And then we have internal energy unknown. So here, atra ikuan gamit gihapon tong general equation for the first law. So we have Q is equals to U plus work. Therefore, our U here mo ay unknown. So we can transpose W, or we can just kanang kuan ato lang ipang substitute usa. So Q is positive, so suwat kag positive 645 kilojoules. Then U plus this 1.2 megajoules, ato sa siya multiply og 1000 para mahimo siya kilojoules para consistent ato ang units. So that would be 1200 kilojoules. Solving for U, so we're going to transpose this on the other side. So we now have U is equals to 645 kilojoules minus 1200 kilojoules. Simplifying this, so we have U is equal to, so 645 minus 1200, negative 555. So our internal energy is negative 555 kilojoules. So may pasabot na yan na, class. We have a negative internal energy. It indicates that our internal energy, unsa man? Okay, decreases. And the same thing with our temperature pod may decrease. So decrease. Wala siya. And then lastly, we have for letter C. So letter C, we have no work here. And we have Q is equals to 5 kilojoules. Then we have internal energy U is equals to 4.22 kilojoules. So here, using again the basic formula of the first law, so we have Q is equals to internal energy plus the work. So substitute lang ang mga values. Q is 5 kilojoules is equals to internal energy is 4.22 kilojoules, then plus work. Solving for work, so transpose this on the other side. So we have work is equals to 5 kilojoules minus 4.22 kilojoules. So the work here is equal to, so 5 minus 4.22, so we have 0.78. That is 0.78. Then this one is in kilojoules. So that would be the answer. And what does it mean? Meaning ang work diri kay done by the system. So work done by the system. So done by the system since this is positive. Okay. So nabay pangutana? Na question ani? No. Nakuara. So here medyo sensei na gini. So again I gid ka kalimot o kan pag-indicate sa sign. So if bali na gyud sign meaning lahi na pasabot ana. So let's proceed to the second one. So ano siya sa old book. So this is from mechanical engineering board exam. So we have here a problem. A group of 50 persons daw attended a secret meeting in a room which is 12 meters wide by 10 meters long and ceiling of 3 meters. The room is completely sealed off and insulated. So each person gives off 150 kilocalorie per hour of heat and occupies a volume of 0.2 cubic meter. The room has an initial pressure of 101.3 kilopascal and temperature of 16 degrees Celsius. So calculate the room temperature after 10 minutes. So here, let's draw the problem. Okay, let's draw the problem. So naday room. Okay. Natay room. And then kaning room kay sealed off and insulated, meaning walay heat transfer gikan sa gawas mga musod sa room. So no Q nga mi transfer gikan sa gawas ni siya ngadto sa room. And then naday tao. Okay, naay tao sulod sa room and 50 persons sila kabuok. Okay? 50 persons sila kabuok. Nya kaning tao pod tagsa ka mga tao mi-emit sila og or mi-loss sila og heat. Okay? So may pagawas sila og heat sa inside sa room. And then ang ilang rate kay 50 kilocalorie per hour. So unsa man ni nga process class? Okay? Unsa man ni siya nga process? Unsa ka ni siya nga process? So here, okay, here let's agree mo iban nga okay, wala may heat nga may transfer sulod sa room. Maybe adiabatic ni siya and then we are going to follow the kuan. We're going to follow the kanang katong isentropic. But ato sa icon class, better gid nga i-analyze gyud ang system. Why? Because ang atong working substance mugod ani ang atong good system nga i-considered is ang working substance para di ka maglibog basig maapil nimo ang tao or unsa pa. So if we try to pick our working substance, so ato ikuan working substance. Our working substance here is air. Why? Because ang nag-filled sa room is air and then gi-state po diri ang mga ang temperature sa room. So of course, automatic the temperature of the room would also be the temperature for the air around it. So working substance is air. So by looking at the air, so if this is our air inside the room, unsa ka iyahang mga properties? Of course, since we change man siya, diba, this is at 0 minutes. So 0 minute. And then inko na siya after 10 minutes. Okay? We change siya after 10 minutes. Okay, change siya after 10 minutes. So, mo na siya ang mga states. So, be sure po na in every problem, you're going to define the state. So, again, working substance is air. So, focus on the air. And then, we're going also to state the ang mga states niya. So, from 0 minute then until 10 minutes. Kaya diba, yung siya calculate the room temperature daw after 10 minutes. So, again, mo niya itong illustration nga naitaw daw sa sod. So, therefore, by looking at this, walay heat nga mi dagdag sa air. So, yeah, we can say that one that is adiabatic. However, na twist. Okay? However, na twist. Kay for adiabatic, automatic magud mo use dito atong work nga 1 over 1 minus k times P1 V1 P2 V2. But here, by looking at the air, from 0 minute to 10 minutes, since this is sealed off, because of this word sealed off, walay migawas nga air outside. Ang tao pod, assume pod ni nga, wa po mo infiltrate na to nga hangin sa sod. Although nag-breathe ta, but anyways, continuation good ang flow. So, in, out, wa ra gyapon na usab. So, we can assume that the volume of air inside the room is constant. Let's say if we're going to take this as state 1 and then state 2. So, we can say that V1 is equals to V2. So, therefore, ang process de ani is constant volume. So, this is a constant volume process. So, constant volume process. Again, dapat i-analyze gid usa. Okay? So, wala din nag-vary ang volume sa point 1 and point 2. Okay? And then, unsa di ay ang volume 1? Nya, unsa po di ang volume rigid sa room? Kay, ang volume sa air is different from the volume of the room. Why? Sige daw, class. Nganong lahi man ang volume sa air? Volume sa air is not equal sa volume sa entire room. Nganong makaingon man ta na? Okay, naitaw, sakto. So therefore, ang volume sa air inside the room i-minus nimo sa volume sa room minus sa volume sa tao. So mao na siya nga di siya equal sa volume sa room. And what else? Unsa pa may lain nga mga properties nga present ari? Aside from volume, we are given initial temperature T1. Initial temperature daw sa room is 16 degrees Celsius. As stated here, kani siya 16 degrees Celsius. And then at T2, so mo to siya, mo na gipangita T2 wala. How about for pressure? Gi-state ba dira ang nay pressure? So the room has an initial pressure of 101.3. So we have the pressure here P1 101.3 kPa. Then si P2 wala na pod gi state. But anyways, you can use, since this is air, we can use the relation since this is constant volume. So we have P1 T1 is equals to P2 over T2. Okay. However, by using this, because this is Gay-Lussac's law, by using Gay-Lussac's, we can easily solve for T2 unta, pero kay duha may duha may unknown. We don't have P2 also, so therefore we cannot use this Gay-Lussac's law. Can you see? That's why we need another equation. And what else? So may lain yung mga given ari. So inyon daw siya nga ang kada person daw mihatag og 150 kilocalorie per hour. So therefore, nada siya heat nga mingadto sa atong working substance. So di ba? Mao nang pili agad sa imong system ang working substance para di ka maglisod. So if I have here a person, meaning nagrepresent siya sa 50 ka buok, so kana siya midagdag na siya dira. Okay? Dagdag ni input na siya heat, and then that is 150 kilo kanang calorie per hour. That is for each person. for each person na siya. So therefore, pilam day ang total Q. So for 50 person, ang Q is, di ba, 7,500 kilocalorie per hour. So ako na ikuan. So therefore, mo na siya added heat sa atong substance. So after 10 minutes, unsa kay iyahang resulta ni. And also, here, mag-solve na ta. Kaya ang required, so required here is to solve for the final temperature after 10 minutes, T2. So solution. Okay, solution ta. So solution. Again, indicate nimo para di ka malibog, this is a constant volume process. Okay, for a constant volume process, again, our work here is 0. Work here again is 0. Then what else? Okay, ingon si sir. Ganiha pag-derive. Internal energy. Okay, pwede mas what? Constant volume internal energy is M CV delta T. And of course, that is M CV, that is T2 minus T1. Given ba taog kanang internal energy? Wala. Given ba tag mass? Wala pod. CV, of course, we all know that the CV of air is equal to 0.716. So, wa gi-state dira, but dapat kayo memorize ka na mo nang gi-encourage ta mo og pagsag-o sa mga constant. So, at indicate diri for air, CV is equals to 0.716. That is kilojoules per kilogram degree Kelvin. And napod siya CP nga 1.0062 kilojoules per kilogram degree Kelvin. And then its gas constant is 0.287 kilojoules per kilogram degree Kelvin. So muna siya ang iyong mga notes to remember. So here, we already defined the work, the entire energy. Ang wa na lang is ang Q. So, lastly, Q is equals to internal energy plus work. This is the basic formula for the first law. We don't have work, so 0. Therefore, our Q is just equal to the internal energy, that is M CV T2 minus T1. Do we have Q? Yes, because that is the Q being added by the person to the air inside the room. So that is 7,500 kilocalorie per hour. Actually, we can just multiply this one by time para makilocalorie na siya. So, unya na lang. So here, unsa may lacking jud ani, we don't have mass. Mo ni ang challenge ari, we don't have mass. Kung di ka kay ba unsa pagkuha sa mass, tingi jud ka, di jud ka maka-proceed. So mani ang kuan, solving for mass gid ang medyo kan ani. So let's solve for mass first. Any idea unsa ang pag-solve sa mass? Solving for mass. Again ha, para di mo maglibog, unaha gyud define unsa nga type of process ang usa ka problem kay magsunod-sunod naman to based sa kato akong gi-derive ganiya. So unsay pamaagi pag-solve sa mass na ini based sa atong available nga mga data nga naa diri. Any idea? Unsa man class? May idea? Wala idea? So again, kung ingan ni nga nang style, kuan mo, mangita mo og ganang formula nga other formulas nga mo relate pod sa mass. So ay ito nun dumi gamit di gani siya ang ideal gas law. So from ideal gas law, that is we have PV is equals to M R T. And ato i-base sa state 1, di ba? Again ha, ang mass at 0 minute is equal pud sa mass sa 10 minutes kay wa biya ta nag-extract dire. So ang mass is conserved here. Napatay tawag ang conservation of mass. So here we can say that for initial state we have P1 V1 is equals to M R T1. So here we can now solve for M. That is M is equals to P1 V1 over R T1. So solving for the mass, we have given P1. So P1 is equal to 101.3. That is 101.3. Then that is in kilonewton per square meter. That is kilopascal. And for the volume of the air, again, that is the volume of the room minus volume sa person. So the volume of the room is 12 times 10 times 3. So that is 12 times 10 times 3 minus 50 katao multiplied by ang tagsatag sa naka volume is 0.2 cubic meter. This one is 0.2 cubic meter. So again, ang resulting unit for volume is cubic meter. Butang nato. So mas better gid class mag-solve kay mo. So what tagin ang mga units kay para di mo makuan, di mo malipat sa inyong final answer. Again, since this is for air man ang atong working substance. So atong kanon ang iyahang R. Again, nakagiswat diri R, constant ni siya. For air, that is 0.287 kilojoules per kilogram degree Kelvin. So imubutang 0.287 kilojoules per kilogram Kelvin. The temperature here is initial is 16 degrees. So again, kung nag-inusara ra sa temperature, always gid na siya i-absolute. So 16 plus 273 degree Kelvin. So ma-cancel, ma-meter lang ni nga usa, ma-cancel po din si kilojoules class, actually that is kilonewton meter. Therefore ma-cancel si kilonewton, ma-cancel si meter diri, ma-cancel po si Kelvin. What's left is kilogram. So therefore mass gid na siya. So mass here is equals to, to simplify, 101.3 times 12 times 10 times 3 minus 50 times 0.2, then divide by 0.287 times 16 plus 273. So the result is 427. The mass is 427.46, so approximately 427.46 kilogram. Muna siya atong mass. So we already have mass. Kay buwan na po tayo sa CV. Then makasolve na tayo ni T2. Okay? So solving for that one. So here, then natin continue. So we have Q is equals to mCV at T2 minus T1. Okay. So here, divide both sides. So divide both sides by mCV. Divide by mCV. So makancel na siya. Cancel na ni. So what's left is this one. We have T2 minus T1 Q over mCV. So here, pwede na to ni i-transpose si T1 on the other side kaya para si T2 na ma-solve. T2 is equals to T1 plus Q over mCV. Actually, no need na nga si T1 add na po din mo diri og 273. Si T2 add po ni nganuman mag-add ka sa pikas 273, mag-add po ka sa pikas, ma-cancel na sila. So, di na nato i-absolute. Only here ra kay the multiplication mo gani siya. So, lisod kay di ni may kuan. Wa po yung makuha niya. Or pwede ra good para safe ka, tanang temperature i-absolute. Kay kung i-absolute ni mo tanan, automatic yung answer pod ma-absolute pod siya. Okay, so here let's substitute the values. So T2 is equals to T1 is 16 degrees Celsius plus our Q based atong given that is 7,500 kilocalorie per hour. So ato na i-convert, dapat natin kilojoules nini. So we have 7,500 kilocalorie per hour, and ato ikuan since this is 10 minutes man, so as sa ikuan nga ang 1 hour is 60 minutes. And then we all know that may take siya for 10 minutes. Multiply itong 10 minutes kay after 10 minutes man daw. Then next is ang kilocalorie na pod. So we all know that 1 kilocalorie is equals to 4.187 kilojoules. Muna siya yung conversion. All over, the mass here is 427.46 kilogram multiplied by the CV of air. CV is 0.716 kilojoules per kilogram degree Kelvin. Or degree Celsius. Anyway, same na siya. Kani makancel yung kilocalorie. Makancel po ni CR. Cancel CR. Cancel si minute. So, si kilojoules po makancel sa ubos. Si kilogram makancel. What's left is a unit of temperature. Actually, this one, ma-degree na siya. So, therefore, our T2, okay, asa ta siya na. Therefore, our T2 is equals to, ato i-simplify, that is 16 plus, we have here 7,500 times 10 times 4.187 divide by 60, then divide by 427.46 multiplied by 0.716. So the answer is 33.1. Okay, the answer is 33.1 degree Celsius. So muna siya pag-increase sa temperature sa room after 10 minutes. So naipanguta na? Ha? Nakuha ra? So kuha ra. Okay, so ipulay pangutana then let's proceed to the next problem. So kani siya example ni siya sa constant volume process. Actually daghan pa kay example sa constant volume. So mas better mag-practice mo mga solve. And anyways, maghatag po ko ninyo problem set ni ini. So next, we have here a perfect gas has a value of R is equals to 319.2 joules per kilogram Kelvin and K is equals to 1.26. If 120 kilojoules are added to 2.27 kilogram of this gas at constant pressure, when the initial temperature is 32.2 degrees Celsius, find T2, enthalpy, internal energy, and the work for a non-flow process. So again, non-flow process man eh. So masakto siya sa ato ang gid pang derive giniha. So again, we have given data. So this is a perfect gas. So if this is a perfect gas, makagamit ta sa ideal gas law. So we have given R value of 319.2. So 319.2 ni siya. 319.2 joules per kilogram Kelvin. And then ang K niya, mo ni siya ang specific heat ratio nga kuan value 1.26. So this is not air, ang air kay 1.4 man. So other gases na siya. And then what else? If 120 kilojoules that were added, so meaning we have Q, that is the heat, equivalent to 120 kilojoules. And we're going to draw also the system para visualize na to. So if this is our system, so natin system, so even though if Q is added, so therefore we add the Q in our system, Q. Then we also have a mass, given po ang mass. So we have mass of our system that is 2.27 kilogram. And then ayun siya at constant pressure. So therefore the process here is at constant pressure. So indicate nimo process at constant pressure. Okay, so gi-state po diri when the initial temperature is 32.2 degrees. So 32.2 degrees Celsius, that is T1. 32.2 degree Celsius. Then gi-state diri find A, T2, then B, delta H, C, delta U, and D, work. So in our system, we don't know maybe may increase si internal energy or si work kay gi-input sa system or gi-output. So ato lang indicate nga na. So required required in this problem is the final temperature. So mag-change man ang state niya. Next is the enthalpy, the internal energy, and the work. This is a non-flow process. So ma-apply to ato ang gikuan ganiya. Okay. So let's solve this one, class. So solution. So for a constant pressure, so that is for isobaric process. So let's start by having the work W. Okay, work W. So work is equals to P dV, or that is equal to P times V2 minus V1. However, we don't have any given V2 and V1. So unsay lain nga equivalent sa work. Actually, work for an ideal gas, this is also the same as MR, okay, MR delta T, okay, MR delta T, that is equals to MR T2 minus T1. Since we don't have T2, di pa tayo makakuha sa work, okay, di tayo makakuha sa work, we only have T1, so therefore hindi tayo mataglain ni ini. So using the general formula, so general formula for for the first law. General formula for the first law, diba? We have Q is equals to U plus the internal energy. So that is our ato ang U ani. Okay, ang atong U ani is man MCV. So U is MCV delta T plus our work can also be used as MR delta T. And here since man common man si M og si T, so therefore that would be M tapos delta T, then we have here CV plus R. Okay, CV plus R. So we have given R but we don't have kanang CV. So unsang pagkuha nini para makasolve ta. And also this one can also be rewritten as M delta T CP, or rearranging that would be M CP delta T. Since wala man tayo given nga CP, ato na siya pangitaon because we are given Q. Now in this way, if makakuha tag CP, then we can easily solve for T2 because delta T is T2 minus T1. So how are we going to solve for CP? Now going back to Meyer's formula, katong ganiha, Meyer's formula because CV plus R is equals to CP raman gina siya. So CP is equals to CV plus R. Now we all know that the K, the specific heat ratio, is just equal to CP over CV. Mao na siya definition sa K. So we can solve CV in terms of CP. So CV is equals to CP over K. So we can substitute this here in order to solve for CP. Substituting, we have CP is equals to CP over K plus R. Then here, solving for CP, maybe we can transpose this one. So we now have CP 1 minus, so minus din siya. Yes, yeah. So that would be 1 minus 1 over K, then plus I equals to R. Solving for CP, so CP is equals to R all over 1 minus 1 over K. So na natay CP. Then we can substitute this back to our equation. Okay? So, again, balik ta. Solving for T2 ta. We have Q over MCP na lang ni is equals to T2 minus T1. Transposing T1, so we have T2 is equals to T1 plus Q over M. Our CP is kanisiya. So therefore, we have multiplied R over 1 minus 1 over K. So again, kani gi-divide lang ni diri automatic MCP. Gi-divide po ni MCP. Here, i-substitute na dahil ang mga values because we have given T1. So initial temperature is 32.2. So butang 32.2 degrees Celsius. Q here is 120 kilojoules. So 120 kilojoules. Divide by the mass here is mass is 2.27. Mass is 2.27 kilogram. Here our R is in joules. And since we have kilojoules here, mas mayong ato i-transform into joules. That is 1 kilojoules equals to 1,000 joules para makancel sa ubos. Our R is 319.2. That is 319.2 joules per kilogram ni siya Kelvin. Joules per kilogram Kelvin. Divide by 1 minus 1 over K. Our K is 1.26. So 1 over 1 minus 1.26. Okay? So here, unit analysis. Makancel ni ang units ng kilojoules. Kani makancel ni makancel. Ang joules would makancel sa ubos. Kilogram makancel. What's left is the temperature. So therefore, our final temperature T2. So T2 is equals to, ato i-simplify. So we have 120 times 1,000 divided by 2.27 multiplied by 319.2 the all over 1 minus 1 over 1.26. So the answer is 66.37. The answer is 66.37. So mana siya pag-increase. Mana siya pag-increase sa temperature. So from 32 to 66.37. So that is the value of our T2. Okay? Mana value sa ato T2 66.37. Ato butang dire, so we now have T2 na. So bandan T2 is equals to 66.37. Actually approximate value degrees Celsius. Now, atra po i-solve si enthalpy. So, solving for enthalpy. Okay, solving for enthalpy. Actually, sa'yo na pag-solve sa enthalpy. Because for a constant pressure, okay. Nasa like klase? Ang uban? Okay, i-end na lang nako diri. I think last na lang ni and then ako lang i-separate og record ang part 2 ani. Okay ra? Oh, sige. Ato na i-kan siya i-end for problem 3 and then ako lang i-continue ni siya. Okay. Siguro napasayos like klase. So, continue ta sa enthalpy. Now for enthalpy, kaning enthalpy, diba, remember sa ato ang at constant pressure, enthalpy is just equal to our Q. Diba? Because this is equal to M Cp delta T. So that is equal to 120 kilojoules na siya. So this one is equals to 120 kilojoules. How about for our work? So, ato ni kuan. Again ha, equal ang enthalpy ug ang Q for constant pressure. Okay, for constant pressure because ato na po na-derive ganiya. Now, for work at constant pressure, So for work, we have work is equals to P dV. So mao na ang kwan sa work, and then that is P V2 minus V1. Since we don't have any given nga V2 o V1, we're going to use the other equivalent for this one using ideal gas nga law. So in ideal gas law, P dV is just equal to mR T2 minus T1. So we have mass, and we all know the R of the gas, and nakasolve na pud ta sa temperature nga T2. So therefore makuha na to. So for our mass, we have 2.27 kilogram. Our R here is 319.2 joules per kilogram Kelvin. And then our T2 is 66.37 degrees Celsius. Minus our T1 is 32.32. So 32.2 degrees Celsius. So here we have kilogram cancel. Actually, Kelvin and degrees Celsius, since this is change in degrees Celsius, so automatically equal na siya sa degree Kelvin. So makancel na po ni. What's left is joules. So joules ang kwan sa tong work. So work, simplifying, we have 2.27 times 319.2 multiplied by 66.37 minus 32.2. So the answer is 24,722. Work is 24,722.81 joules. And in terms of kilojoules, after the approximate value na siya, work is equals to 24.7 kilojoules. So muna siya ang value sa work ani nga process. So therefore ato na nakuha ang upat: the work, the enthalpy, internal energy, and the temperature at kanang point 2. So nakay pangutan na? Nakuha ra? Kuha ra. So if wala na kay pangutan na, then let's end na lang for this kaning part.